So good morning, guys. Today we are starting this master program. The master program includes CCNA, CCNP, NRC, and Palo Alto. So from the initial, we are starting with the CCNA. For the CCNA, Rahul is the trainer who gonna deliver the entire content for this. So Rahul, over to you. You will start with the introduction and today is a demo session, guys. And from next Saturday, we have a proper classes for this particular master program. Okay, starting from the CCNA. Yeah, Rahul, over to you. I'm giving the host access now.
Thank you. Good morning, everyone.
Good morning.
Good morning, sir.
Good
Good morning, sir.
morning, all. So let me actually share the screen so it's visible to you. So we'll also see what more things we'll learn. So the first part is CCNA, which is actually the right part to start with, right? Because you know that we need to know how to build the network, right? First of all, we'll be looking at CCNA, which stands for Cisco Certified Network Associate. Hope you all can see my screen, right?
Yes, sir.
Okay. CCNA stands for Cisco Certified Networks Associate. Now, what does that teach you? That actually teaches you that we have many network devices in our telecom industry, right? We have routers, we have switches, we have firewalls, right? We have end users like the computers, right? But how to establish connectivity is what your network teachings actually teach you. How to establish these connectivity. I know that you all establish the connectivity through the wires, right? We connect the wires from one end of the cable to this device and the other end of the cable to this device, right? That is not it. Just by connecting the cable from one end to the other, does the information get passed on from one router to another switch? No. Does the information get passed on from from one switch to another PC? No. It takes lot more than that. That is what we'll be learning in this entire CCNA. First, we'll understand what are the network devices that we are using in CCNA. That is basically not only in CCNA, we are learning.
शाम में मेरी क्लास चल रही बाद में बात करेंगे.
Yes, please be on mute. Sure that, but yeah, I think we are on mute now. All right. So we'll be basically, as I told you, we'll be learning what are the devices that we actually use in our telecom industry, right? And how do they behave? For example, how does a router behave? How does a switch behave? What does a computer do? Right? What does it actually want? These are the things that we learn in Cisco Certified Network Associate. When it comes to CCNP, you learn something more deeper. Means not only you know about these guys, what they do, but also you know that with the help of this, can I use another router, more upgraded one? Or for these number of people in my company, is it okay to, can I handle with this router alone? Or do I need something else? That is what you'll learn in CCNP in a bit of more depth, right? You will take it in more depth. Apart from that, you're learning Palo Alto also in your master program. Why is Palo Alto required? Because once you build the networks, for example, now you know router, what it does, computer, what it does, switch, what it does, you know everything, right? Now you connect one device to the other. But after connecting those devices, you might know that there might be some security required for all these devices. The data that travels from one system or from one device to another, that needs a bit of security. At that point of time, you will need Palo Alto or some other firewall, which the current one, which is, in trend, is also Palo Alto. So we are actually going in the right direction. So first we are learning how the network devices react, how they can be used in a network, how they can be designed. And after design, after knowing how they behave, how the packets travel from from one device to another, then you're implementing security on that. So it is kind of, we are having it in the right sequence, I would say. Right? Having said that, let's go to our CCNA. Let's see what we are learning in the CCNA. Right? The first thing, we have many chapters or many units that we are going to cover in CCNA. The first one will be the introduction. Right? In the introduction, I'll tell you what are the basic, what are the basic things that we do, what is networking and stuff. The next thing we have is network fundamentals. So guys, this is the syllabus that is matched with the Cisco CCNA website as well. And this is the syllabus from which you will be getting the exam questions as well. So I'm just writing it here so that in case if you guys miss out on the syllabus somewhere, if you're seeking for CCNA exam or something, you need to know the syllabus, what all is covered in our CCNA syllabus. You need to know that. That's the reason we'll all have it written here. Then we have network access. So what does network fundamental cover? Network fundamental covers the basic knowledge of the networking, like the OSI model. What is a header? What is the meaning of a header? Right? That is what we cover in network fundamentals. What is network access? Network access means, the word access means that whenever you are entering a network. So for example, I am a user, right? I am a user. How do I enter any network? Through my computer, right? Through my computer. When I do some actions on my computer, I enter a network. Where is the computer connected? To a switch. Is the switch connected only with my computer? No. It can be connected with several other computers. So this portion, entire portion, is known as network access, because I am trying to access the network through my computer, and through the switches I'm getting inside the network. That is known as network access. The fourth, IP connectivity. What does IP address mean? Right? How do people assign IP address? Is it random? Is it assigned random? And from what IP address to what IP address I can assign to a particular device? Can I assign any IP address, or is there a way, is there a sequence? Right? We'll all learn that in IP connectivity. Apart from that, we have IP services as well. In IP services, we'll see other services. What are the other services? So for example, we have to monitor this guy. what he is doing, or let's say this link is down, or this wire is, gone wrong, this wire got cracked somewhere, right? We are sitting in one station observing all the things that are happening. How do we do that? This is possible through the use of IP services, IP protocols, right? That help us to do all these things. Or as an administrator, I can't go to every computer, assign an IP address, because for every device to communicate, right? They need an IP address. Without an IP address, they cannot communicate. So do I go to every computer? Let's say there are like thousands of computers in a building, in a company. Do I go to all the computers and assign the IP address? Is it not a very heavy task on the administrator? It is, right? So why don't I, program something which automatically, once the computer comes in, connects to any network access, it automatically gets an IP address assigned. Wow, how is this done? This is done through IP services, right? I'll tell you what protocols we use that in IP services. Then we have security fundamentals. Means it is not that in CCNA we are not learning about security. We are still learning about security. But in the Palo Alto section, you are going something more into security, right? Here we are giving a brief introduction about security also, right? What happens now if I connect like this? Would there be possible attack, or would somebody steal my data? If he steals my data, how does he do that, right? And what are the chances that I can prevent data from getting seen by other attackers? We'll discuss all that in this section. And also we have network management. Network management is, so for example, you know that you get a router or switch from a shop, right? You connect it however you need as per your requirements. But you know that you have to sit in one place and manage them all. Means you have to log into this switch and say, no, this is using, I'll turn off this port, I'll turn on this port, or I'll turn on this port. So, or you can say, what is the CPU percentage of this router? Is it gone past the threshold value, right? I have to see how much of the memory is being used for this router. So this is called the management things, right? Means sitting at one on place, logging into different devices and seeing, how are they? Are the devices fine? Are they working properly? Is all the functions right about a network device? This is called as a network management. And not only that, also you have some management level. So what is the next device that is connected to me? I don't know, because I am only logged into this device. As an administrator, if I am given a diagram like this, I can know what is this. I know that this is a switch too. But when I'm logged into this device, how do I know which is the device which is connected to me on the left hand side and the right hand side? These are all the things. So there are particular protocols for that, which helps you in knowing all these. These are the management protocols, is what we call. Why we call them management protocol? Because they help in managing the devices. For example, another protocol which helps to set the time. So for example, this is one of the switch, this is another switch. How to set the time to be synchronized between switch 1 and switch 2? Again, with the help of management protocol, right? So for example, my phone and your phone is Android OS. We are synchronized to a time and it is 9:16 now. We know that. How is it synchronized? Because of the time protocol. There is some protocol which synchronizes the time, right? For all of us. That is again network management protocols. Then after that, we'll talk about the network design, how the network is designed. We'll first know about all the devices, how they work, how they are connected, right? How they are given IP address, how to implement security on that. Then we'll talk about which devices are connected where. That is network design part, right? Then after that, we come to the very interesting unit. Why I'm telling interesting is because it has been added recently to CCNA portion, right? It consists of automation and programmability. You don't need to worry, right? We all know that, right? Even I am not from a coding background. Even if you're not from a coding background, you need not worry that, okay, once I see programmability, do I have to program anything? No, it is not such a way, not for the CCNA level. But in CCNA level, we will get to know that which part is programmed, right? Which part is automated, which part is programmed, right? We'll come to know that. And what are the protocols? What are the tools that we actually use to program anything? These are the things we will get to know in that portion, automation and programmability. So this is the syllabus that we have right now, right? We have this syllabus. If you find, or if you want, you can write it down. That is completely okay. But all the things that we are going to discuss will fall in one or the other sections, right? I hope there are no doubts till here. Maybe in syllabus, if you want, you can take your time. You can take your time, verify the syllabus, and come back to me. That's not a problem. But for now, let's actually move on from the syllabus, right? So in today's class, we are going to have a brief introduction. Like, why do we need CCNA? First of all, then why do we need CCNA? I will be answering this question in a bit, right? As and when we start learning, because why do we need CCNA? If I tell you that, switch is capable of so and so functions, router is capable of so and so functions, maybe you will not even understand the capability. So what do you mean by routing from one network to another? What do you mean by switching? Using that protocol, I'm doing switching. So that is why we need CCNA. You won't understand that part. So if I explain you what are the switches, what are the routers, these are the functions the routers can do, and then I tell you that is why we need CCNA and these network devices. That is why we are learning CCNA, so that these network devices help us and so and so. And that would be the appropriate time and time to understand why we are actually implementing and studying CCNA. Right? Now, let's understand what is a network. Network is nothing but the collection of network devices, right? The network is nothing but the collection of network devices that can talk to each other, right? That can talk to each other. Networking is nothing but making the information pass through these network devices. So basically, when these guys communicate with each other, that is known as networking. Collection of network devices is known as network. Now, there are many kinds of network. So what do you think? So inside an office, so for example, this is my office building. right? This is my office building. Yeah, of course, everybody would be, in the corporate, they would know inside their office, see, uh, there is first floor, second floor, and third floor, right? And you have your own computers set up, right? You have your own computers set up in the first floor. You have computers set up in second floor. I mean, first floor, and then, ground floor. You have your own computer setup in the office. And what we're doing, this is called as what kind of a network? It is our internal network. Why it is known as our internal network? Because this network belongs to our own. This guy is also my company. This guy also belongs to my company. The computer guy who is sitting on the second computer also belongs to my company. So this is our internal network, right? That is known as the local area network, right? Local area network. When do I call a network as a local area network? When it is internal, means I am not talking to anybody. I'm sitting here in the office. I'm not talking to anybody who is sitting in another location like US and talking to another guy who is in that building. That kind of network is known as wide area network because I am talking over a public network. I'm talking over a public network. But what is happening here? There would be a switch here. All the computers would be connected to a switch. If I want to communicate from this computer to this computer, basically I would go to a switch. Through the switch, I would talk to this computer. So I'm talking internally. I'm talking internally, right? The communication is happening internally. That is why it is known as local area. But here, the communication is happening over the internet. So, for example, you're using an Android phone and you have your Wi-Fi modem connected. You are connected to that Wi-Fi. That is okay. But if you browse something on your phone, it goes to the Wi-Fi modem, and after that, what happens to the traffic? Obviously, it goes to your service provider, whoever has given you that Wi-Fi modem. It will go to that guy's router and he will take you to the other side, maybe the Google server, anywhere. Now, you know that the information is not safe here. Why? Because not only me, after this router on this cable, before reaching the Google server, it's not only me. Many guys are accessing this network. Many guys are connected to this network, not only me. That is known as internet or it is known as wide area network. Why wide area network? Because it is not limited to one particular building. It's connecting from two different cities or two different countries, right? So it is known as wide area network. So, I mean, the second type of network that we see is wide area network. Now you might ask me, so if there is wide area network and if there is local area network, are the network devices that we use differ? Do they change? Do we use different devices in wide area network and do we use different devices in local area network? No, it is all the same. We use the same network. We use the same network devices, right? We don't change our network devices. It is the same. Only thing is that once it goes out to the internet, it goes out of our building, the information is not in our hands. Means it is controlled by maybe the service provider. Whom do we call as a service provider? You would know by now, but still, maybe the company who is giving you the internet is known as service provider, internet service provider. He also provides you with an IP address. There are different types of networks as well, like, metropolitan area network. We have many networks like that in the subcategories, but I'll just mention the local area and wide area. That is actually enough for now. Moving on, we have the network actually started with a computer. They discovered a computer. They were very happy about, a computer was discovered and it was doing a lot of functions. Microsoft Excel, right? It was used to calculate something, and they shared, or they kept many files within this computer, saying that I can do this, I can do that. Many files were there on this computer. But only problem is they were not able to share this with anybody else. If I want, so if he gets another computer, maybe the neighbor, I am not able to share the information with him. Right? I'm not able to share the information with him. Again, I have to put it in a hard disk or floppy or whatever which was available and give it to him. Right? And he used to put that in his own computer and access that information. But imagine what happened as and when the computers started growing. As and when the computers started growing, you came to know that the information has to be shared between one computer to the other. I cannot manage with floppy, hard disks, right? CD, I cannot manage for a long time. We need information to be shared. Only then, for example, there is a data center. I have kept a file here. I want everybody from my branch offices to access this file. Let's say a report or end of the week report. Everybody has to upload their report here in this SharePoint. So you need to access that file. Even you need to access. Everybody needs to access that. Right? So sharing of data became more important. So they said, if I connect from one computer to another computer directly, I can only have one computer connected, because you know that your computer do not have two ports, Ethernet ports. You just have one Ethernet port on your system, right? Ethernet adapter, you can just see one. How to see if I have Ethernet ports or not? Just go to control panel, maybe. Control panel. Network and internet. Network and sharing center. If you go to change adapter settings, you'll see all the adapters. These are the virtual adapters. Anyways, I'll tell you what is virtual, what is logical, what is Ethernet. This is something known as Ethernet, right? What is Ethernet? Ethernet is a collection of standards. Collection of standards in the sense it is set of rules that you have to follow when you are connecting device to device or many devices together in a company. If you are connecting many devices together in a company, then you have to follow the Ethernet rules. And the port that is on our computer is known as Ethernet port. the cable that we connect to the port on our computer is known as Ethernet cable, right? They have different speeds, they have different standards, right? There are different standards for Ethernet: 10 gig, 1 gig, 100 Mbps, 1000 Mbps. We'll discuss that. But just telling you, there is only one Ethernet port on your computer. So max to max, you can connect how many computers? Just one. With a cable, Ethernet cable, I can connect only one other computer. But what about others? I cannot, if I want to share information with these all, then where do I go? Right? That will become a problem. So what they did, see, let's not actually build the computers like this, where I have to take the cable and connect to every other computer. Let's not build the computers like this. Let's discover a centralized device and I connect to only that, right? I connect only to that. What happens? Every computer can talk to every other computer with the help of this centralized device. I am only connecting to the centralized device. I'm not connecting to, I don't have to connect to every other computer. If you had to connect to every other computer, just by having 3 computers or 4 computers, see how many connections you have. I have to connect to this guy, this guy, this guy. From here, I have to connect to this guy, which is already there, this guy, this guy. From here, I have to connect to this guy. So it is kind of a mesh, right? Mesh connection. You will have to have many cables, many cables for one computer. 1, 2, 3. 3 cables, because there are other 3 devices. What if the computers go on increasing? The number of cables will actually kill us, right? The cables are more expensive. I mean, the cables will become more expensive for us. So they designed in such a way that I'll I'll use a centralized device called as a hub, right? I'll use a centralized device called as a hub. Let every other computer connect to this hub. Through this hub, we can contact or connect, communicate any other computer. Right? That was the idea. So hub came into existence. Now, how was this hub? Was it, was it effective device? It is a networking device. We call it as a layer 1 device. What is a layer 1 device? We'll talk about all the layers very soon. But the main function was of the hub is how did the information travel to PC2, right? How did the information travel to PC2? Let's say this is PC1, PC2, PC3, PC4, PC5. Let's say PC1 sent any information on this wire or the Ethernet cable that is connected between the hub and the PC1. Now hub received it on port number 1, right? The hub received it on port number 1. I'll take off this computer which is connected here. Right, let's not complicate. Let's have just when the hub receives something on port number 1, the most common behavior of the hub is, okay, I received it on port number 1. I will send it to port number 3. I will send it to port number 4. I will send it to port number 2. But I will not send it back again on port number 1. So the behavior is if I get an information of one port, I will be sending the same information on all other ports. If you buy a 16 port hub, means hub which has, then if I get information on one port, I will be sending on all other 15 ports. But I'll not send it back to the same port which actually, from which actually I got the information. Now, this is something known as broadcast. Means if I got any information, I will send it out on all other ports. That is fine. So how would the other PC, how would the other PC take it? So let's say this is 1.1.1.1, this is 1.1.1.2, 1.1.1.3, just for, reference. I'm just giving you the IP address. Let's say 1.1.1.1 is sending the information to 1.1.1.2. So it will have written here, where it would be written in the IP header. I am sending this to 1.1.1.2. Now the information is sent this guy also. This how? Because here inside the hub, the information was sent out of this port. Now the information will be sent out of this port, sent out of this port, sent out of this port. Now this guy who receives, the computer which receives that information, checks the header. For example, you write a letter. Once you write a letter to somebody, do you just post the letter as it is in the post box? You don't, right? You actually put an envelope to that. And say what is the from address and what is the to address. You naturally do, right? Why you do that? Because you know that if I just post the letter will not reach the concerned person on the other side, because the postman or the post office does not know where to take this letter to. That's the reason I write the from address and to address. Why do I write the from address? Because the receiver, if he has to write any information to me, he should know where to reach me, right? If he does not know, of course, when you write an information or letter to him, it will not be always the information that you want to give him. You also need some information from him, right? So where would he send that information to you? He needs your address, right? That is this one. Every computer which generates information, not only it sends the data, because by now everybody knows that the computer works on the information that the computer can access is on ones and zeros, right? This what is your name is only available for human eyes, because humans can read it. Computer only represents ones and zeros in the form of what is your name, so that it is easy for humans to read it, right? But computer actually processes information in ones and zeros. Now when the information is going to switch the hub, it will also write the from address and to address. Where is it writing this address? Inside the data itself? No, it will not even touch the data, but to the actual data, it will add something known as header. Right? Just like your envelope. We call this envelope in our posting world, right? To write the from address and to address. The network calls it as headers. Means some of the information of the source, some of the information of the destination is written in the headers. Now, this guy, obviously he received the data along with the headers. Who is sending 1.1? Who is the receiver? 1.2. But he will check. I am not 1.2. I am not 1.2. So what does this guy do? Obviously, he'll deny the packet. He'll deny the information. What does this guy do? Obviously, if you get a letter from somebody else, will you be able to? I mean, I know that some curious guys will definitely read it, but if it is not you and you are very busy, if it is not your letter, if it is not written to you, then you'll definitely discard the packet, deny the packet, and not process it. Does your brain, you know, give? You're a very busy person, and does your brain say that, okay, I'll read the letter and I'll process that information? No. You're a busy person. Why do you want to process unnecessary traffic? The CPU of this computer, why does it need unnecessary traffic? It does not, right? So it will discard the packet. This guy will see the header first without even going inside the letter. Everybody does that without even going inside the information, actual data. He will read the header. Okay, this is for me. Then he will tear this envelope, just like how you tear the envelope and get inside the letter. Just like that, he will tear the header and access the data, process the data by his CPU. This was the procedure when we had hubs, right? When we had hubs. Now, yes, you can ask me, what is the problem? There was no problem. Do we use hub now? Is everything going fine? Yes. Nowadays, we do not use hubs. The reason is, only reason is when we have a hub here, when there is a port, we have 4 systems connected. The information coming from here on port number 1 would be scattered to port number 2, right? Come on. Port number 2, this is port number 2, this is port number 3, 4. It would go to all the ports except the port which is receiving it. So now, okay, what is the problem in that? I want to understand. The problem is simple. The problem is, you know the problem. I already explained it to you. Now, what if this guy is sending an information? Let's say, let's write it in red. Right? Let's write it in red. You can see what is happening actually. Now this guy is sending an information. It is going here to this computer, this computer, this computer, right? Because once it comes here, it goes like this. It goes to this port also, this port also. We have a 4-port hub, imagine. Now what if this guy is sending the information at the same time? Information is going here, going here, going here. What if this also is sending an information at the same time? It will go here, it will go here, go here. Similarly, this guy sent an information. Obviously, it goes here, it goes here, it goes here. So you can see that the information that this guy is sending, is only to this computer. But all are receiving it. All are receiving it. Now, let's consider this is a water pipe, right? This is a water pipe. This is a water pipe. I know everybody would have seen water pipe. In this pipe, only 2 liters of water is possible. Only 2 liters of water is possible in this pipe to flow, right? Now, this guy sent an information, right? This guy sent an information. Hey, I have an information for this guy. Okay. The whole 2-liter water is filled. 2-liter pipe is filled. He got the information. His 2-liter pipe is filled. And along with that, these guys' 2-liter water pipe is also filled. But they want to send another information. They both want to talk at the same time. They can't. Why? The pipe is filled. They're not able to send any information on the pipe. The pipe is filled. I have to process the information which is coming to me, or the process the water which is coming to me on this pipe. First, I have to clear that water inside this pipe. Only then I can send anything on this pipe to this computer. You're understanding what is the problem? Right? The bandwidth of this link in technical terms, the bandwidth or the size, maybe you can call the water pipe, was actually occupied unnecessarily, even though it was not processing the information for itself, for any unnecessary data which is not even destined for that computer. It was busy processing those unnecessary data. That is the problem with the hub, because it used to broadcast the information. Means if I get on any port, forward it on all the ports. That was a big problem. When the computers were minimal, they used to, suffice the problems to certain level. But as and when the computers started growing, any broadcast, let's say we have like 50 computers, one small broadcast or one small information from one computer would disturb all the 49 other computers. That was the problem. So what did that do? How did we actually come over it? They invented another device known as switch. And this time, they did not do the same mistake. They did not do the same mistake. They thought this idea of broadcasting using a centralized device, which are the centralized devices here? The hub, the switch. These are the centralized device. Why? Because we connect all the computers to these guys, and through them, we are talking to other computers. That is why we call them as centralized device. Now they decided any other centralized device that we actually find out, it should not do a broadcast. It should not do a broadcast. If they do a broadcast, then it is waste of bandwidth. The network is not efficient. Right? Now they decided I'll use a switch. Now they decided that they discovered a new device called as a switch. What does a switch do? Actually, what switch does is, switch is an intelligent device, right? It maintains something known as MAC address table. I'll tell you what a MAC address is, right? For now, you understand that every PC has MAC addresses. Every PC. means is any device, for example, my mobile is able to communicate through the network to the switch, to the router, etc. My router is able to, my printer is able to communicate with the network, with the switch, with the, right, with the switch, with the computer. Why my, I have a cricket bat at home. Why is that not able to communicate with the network? The problem is the network interface card. Your computer has a network interface card here. All your computers. Your switch has a network interface card at the point where at the slot where you connect. This network interface card is the one which is responsible for networking, that is communication between the devices. Without network interface card, you cannot communicate with another device. Now, what is this MAC address on the network interface card? On the network interface card, you would have heard of the NIC card, network interface card. So you connect to a slot on the computer. On this slot, why do you connect it there? Because you have a network interface card on that slot. And that network interface card, it has an address that is known as MAC address. Every device has it, every device. And no two devices can use the same address. It has to be unique. For example, if my name and my surname, my initials, has to be different compared to other person, right? That's our identity. If any two devices have the same, everything as the same, name, everything as the same, then the identity. So if I call, so let's say two guys named as Pawan. If I call Pawan, obviously both will actually respond, right? Both will respond if I call Pawan, because both of them have the same name. Similarly, if both network interface cards have the same address, when the packet comes here, where should the switch forward? Here or here? Right? It becomes a conflict. It becomes a confusion. So every network interface card is designed in such a way that it does not have a same address. All the network interface card has a unique address. They don't merge. They don't, have the same. Similarly, that network interface card has an address. What the switch does is, it knows once an information comes from this computer to the port 1 of the switch, immediately it will write down, my port number 1 is connected to somebody called AA. Now you might ask me, how does the switch know that he is connected to, the computer connected is AA? Because you know that the computer sends a data information just like how we write a letter. And does it only send the data? No, it sends the header also. In the header, it will say, I am coming from a MAC address. My MAC address is AA and I want to go to BB. The switch reads that header information. Okay, somebody called AA is coming and they want to go to BB. Then it will check, do I have in my MAC address table anybody called BB? No. If I don't have, then I'll push it to everybody else. The other guys who are not BB, they will, obviously, deny the packet from processing, BB will respond, hey, I am BB. Then it will again make an entry. The switch will again make an entry. When BB replies to AA, okay, port number 2 is connected to BB. What happens next time when the PC is sending message to BB? Now the switch has built its table. It will read the header. Okay, you want to go again from AA to BB? AA is connected to port number 1, but BB is connected on port number 2. Let me only forward you to port number 2. It's an intelligent device. It learns the traffic on the go. Right? So this is how actually that invention of a switch made a difference in the network industry. Right? We actually had more benefits using the switch than a hub. Nowadays, we don't use hubs anymore. Hubs are all vanished. We only use switches, and these switches consist of this network access layer. Means computers and switches connected together form our network access layer, because through them we are accessing the networks, right? So we'll talk about the fundamentals also in the next class, just to make sure our basics are clear before we move on with the deeper topics. But for today, till now, do we have any doubts? Do we have any confusions? Or do you find any problem in understanding? Are we guys good till here?
Yes, fine.
Okay, awesome. So if you guys need me to slow down or go a bit pacey, just let me know. But if you ask me, I usually train in a slow way. I mean, my pace is little slow, but you can let me know anytime that if you want it to be better or if you want it to be pacey, you can let me know. But for today, I'll just leave it at this. I don't want to bug you more on the first day itself. So I'll just stop it at this point. So please let me know if you have any doubts. If you do not have any doubts, then we can wind it up for the day. All right. I'll take that as none. Okay, guys. Thanks. Thanks a lot for joining in. Thanks for your time.
So we'll meet on Saturday, next Saturday.
Yes. So the regular class starts from next Saturday, Sunday, and it would be 10 a.m. IST. Are everybody okay with the timings?
I think I got an intimation from 9, I suppose. No issues. You let us know.
Okay, let me know. Please let me know if somebody has any problem with 10 a.m. IST. Even if it is 9 a.m. IST, I'm okay with that. I do not have any problem. Only thing is, I mean, yes, I also do work in an organization, which actually I log out like, in the midnight at, 2:33 or something. So 10 would be better, I thought. But however you guys are comfortable, please let me know if you are not okay with.
Yeah, it will be okay at 10.
Are you okay
Fine,
with?
10 is also fine.
Yeah, right then. Okay, somebody says 9 a.m. Pradeep. All right, so not a problem. So let's discuss actually maybe in the next class. So in the next class, for next class, let's actually uh see if oh, these are mixed opinions. I know only Pradeep says 9 a.m. Let's see what can be done. Anyways, so in the next class, let's meet at 9, however it is as of now. Maybe if there can be anything that Pradeep can adjust, we'll see. Otherwise, we'll carry on from at 9 itself. Okay. That's all I had. If you have anything, please, you can ask me or we can wind up.
Thanks. We are fine with it.
Right? Thanks everyone for your time. Have a good weekend.
Hi, Rahul.
Yes.
You there?
Yes, yes.
Yeah. What will be the total time for CCNA, like total period of course?
I'll take about 2 months to complete it
2 months, right?
because
Okay.
it is just the weekend batch. And actually, trust me, it is actually a bit slow. Have anybody any any have you set up any goals of certifications? Do you have a date, scheduled a date for certification or anything? Because if I if we start off the class with 2 hours or 3 hours every day, or every weekend, if we sit for 3 hours, then it would be all of a sudden it would be putting a lot of burden on you. Like 3 hours together, I don't think so you can take it. But if you could take it, we can, conduct the classes for. I usually take the CCNA class for 1 to 1.5 hour, not more than that, because I feel that a lot of concepts in a day would not actually give you much knowledge. But any which ways, however you guys are comfortable, we can discuss on a daily basis. Whenever we go through a class, we can see if people are ready to learn more, or we need to stop at a point. We can discuss. And so if it is 1 hour, then it can go past 2 months, 2.5 months. But if it is more than 1 hour, 2 hours, then I can finish it in 2 months.
Okay.
Right then. Happy weekend, everyone.